Next hybridization is Sp2 hybridization. In name itself Sp2 is present, that means one s and two p orbitals. So what is the definition? The intermixing of one s orbital and two p orbitals, one s orbital and two p orbitals to give 3 Sp2, because here 3 atomic orbitals are intermixing, one s and 2p, then we get 3 hybrid orbitals. They are 3 Sp2 hybrid orbitals. This phenomenon is called Sp2 hybridization. Example, BCl3, boron trichloride. In this BCl3, what is central atom? Boron. Boron electronic configuration is what? 1s2, 2s2, 2p1. This is orbital representation. If you observe this orbital representation, boron contains only one unpaired electron, but BCl3 is formed. That means boron should contain 3 unpaired electrons, but here only one unpaired electron is present in ground state. So to satisfy this condition, boron should undergo excited state, that is called first excited state. Then its electronic configuration becomes 1s2, 2s2 becomes 2s1 and 2p2. Now in this configuration, boron contains 3 unpaired electrons. See, one is present in 2s orbital and 2 are present in 2p orbitals. Now the unpaired electron which is present in 2s and the unpaired electrons which are present in 2p subshells undergo intermixing. That means 1s and 2p orbitals of boron undergo intermixing. Then 3 hybrid orbitals are formed. Those are called what? Sp2. Now boron contains how many orbitals? How many hybrid orbitals? 3 hybrid orbitals. Those are represented by Sp2. Now these 3 Sp2 hybrid orbitals of boron overlap with 3 unpaired electrons of p orbitals of chlorine atoms. Then 3 sigma bonds will be formed. Before that, these 3 Sp2 hybrid orbitals, that means after forming hybrid orbitals from atomic orbitals, these hybrid orbitals are arranged trigonally around boron atom, like this. This is boron atom. This is one hybrid orbital. This is another hybrid orbital. This is another hybrid orbital. This is Sp2. This is also Sp2, Sp2. All are having one unpaired electron. This is trigonal arrangement. That means before going to intermix with the p orbitals of chlorine, they are arranged like this. Why they are arranged like this? Why they are arranged like this only? Because when they arrange like this, then only the repulsions between these orbitals will be minimum. When they arrange like this, then the repulsions between these orbitals will be minimum. Now after arranging like this, after arranging hybrid orbitals around central atom, these hybrid orbitals are going to overlap with p orbitals of chlorine atom. P orbitals of chlorine atom. Then what happen? Bonds will be formed. After overlapping, every time bonds will be formed. BCl3. So this is the structure for BCl3. Its shape is trigonal planar. Trigonal planar. That means all atoms present in plane. If you pass one plane, all atoms are present in that plane. Hybridization is Sp2. Percentage of S character Sp2. That means 1s and 2p. So percentage of S character is how much? 33.33. Percentage of p character is how much? 66.66. Here three orbitals are present. 100 by 3. How much? 33.33. This is for what? For one orbital. Here 2 orbitals belongs to same category. That means 2 orbitals belongs to 2 p orbitals are present. Those are same category. So the rest of remaining percentage belongs to percentage of P character. So finally percentage of S character is 33.33, percentage of P character is 66.66. So this is all about Sp2 hybridization. So in case of Sp, what is shape? Linear. In case of Sp2, shape is trigonal planar. In case of Sp, bond angle 180. In case of Sp2, bond angle here, bond angle is 120 degrees between any two sigma bonds. Or if you take these two sigma bonds or these two, bond angle is how much? 120. Next, in case of Sp, percentage of S character is 50. Here percentage of S character 33.33. Here percentage of P character 50. Here percentage of P character 66.66. So this is all about Sp2 hybridization. Next concept is, next type is Sp3 hybridization. Sp3 means 1s and 3p orbitals going to intermix. So what is the definition? The intermixing of 1s orbital and 3p orbitals to give 4 sp3 hybrid orbitals is called sp3 hybrid orbitals. That phenomenon is called sp3 hybridization. What is the example for that? CH4. In CH4, central atom is carbon. Its atomic number is 6. Its electronic configuration 1s2 2s2 2p2. In this electronic configuration, carbon contains 2 unpaired electrons, but here CH4 is formed. That means carbon should have 4 unpaired electrons. To satisfy that condition, carbon should undergo what? Excited state configuration. That is also called first excited state configuration. Its configuration is 1s2 2s1 2p3. Excited state means lone pair becomes unpaired. Then 1s2 2s1 2p3 configuration will come. In that configuration, 4 unpaired electrons are present. Now these 4 unpaired electrons of 4 orbitals undergo 4 unpaired electrons of 4 orbitals of carbon atom. 4 unpaired electrons of 4 orbitals of carbon atom undergo intermixing. Then 4 hybrid orbitals will be formed. Those are represented by sp3. After forming hybrid orbitals, they arranged around carbon atom in tetrahedral manner. I repeat this point, listen carefully. After forming hybrid orbitals from atomic orbitals, they arrange around carbon atom in tetrahedral manner. That is like this. Tetrahedral means 4 come, 1 come, 1 from 1 is like this, 1 more is like this, 1 more is like this, and last one is like this. This arrangement is called tetrahedral. Now carbon contains 4 hybrid orbitals. Those hybrid orbitals are represented by sp3, sp3. Each contain one unpaired electron. Now these 4 hybrid orbitals of carbon atom overlap with what? S orbital of hydrogen. S orbital of hydrogen. Because hydrogen also contains one unpaired electron which is present in s orbital. S orbital shape is spherical. After overlapping, what happens? Bonds will be formed like this. This is called tetrahedral arrangement. So shape is called what? Tetrahedral. Bond angle means what? Angle between two adjacent sigma bonds. If you take any two sigma bonds, here their bond angle is 109 degrees 28 minutes. Here percentage of S character sp3. Hybridization is what? sp3. That means 1s 3p. So total 4, 100 by 4, how much? 25. That means that 25% belongs to S. Percentage of P. The rest percentage belongs to P character. Total rest percent is how much? 75% P character. So in this case, percentage of S character is 25, percentage of P character is 75%. So this is all about Sp3 hybridization. Next one, Sp3D hybridization. Name itself Sp3D, that means 1 s orbital, 3 p orbitals, 1 d orbital undergo intermixing. Then what will be the definition? The intermixing of 1 s orbital and 3 p orbitals and 1 d orbital to give how many? 1s 3p d, that means 5. That means 5 hybrid orbitals will be formed. They are represented by Sp3d. That phenomenon is called Sp3D hybridization. For that example is PCl5. In case of PCl5, phosphorus is the central atom. Its atomic number is 15. Its electronic configuration neon 3s2 3p3. In this electronic configuration, only 3 unpaired electrons are present. These are not sufficient to form PCl5. So to satisfy that condition, phosphorus should undergo excited state configuration. Then its excited state configuration becomes 3s1 3p3 3d1, 3s1 3p3 3d1. In this excited state configuration, 1 s orbital, 3 p orbitals and 1 d orbital of phosphorus atom will involve in hybridization. Then 5 sp3d hybrid orbitals are formed. These are arranged trigonal bipyramidally around phosphorus atom. That means like this, trigonal bipyramidally. This is phosphorus atom. This is one hybrid orbital. This is one more hybrid orbital. This is one third hybrid orbital. This is fourth one. This is fifth one. After forming in hybrid orbitals from atomic orbitals, these hybrid orbitals are arranged around the central atom. In which manner? Trigonal bipyramidal manner, each having one unpaired electron. These are which orbitals? Sp3d orbitals. Now these orbitals overlaps with what? P orbitals of chlorine atom. That means that chlorine atom having one unpaired electron which is present in p orbital. Now they undergo overlapping. They undergo overlapping like this. Then finally which will form, we get this type of structure. Here this structure is called what? Its shape is trigonal bipyramidal. Why we should say like that? See, this is trigonal. This is present above the plane, this is present below the plane. So these are called pyramids. These 4 atoms, these 3 chlorine atoms and a phosphorus atom, these 4 atoms present in plane, this chlorine atom is present above the plane, that is why it is called pyramidal. This is also present below the plane, that is why this is also called another pyramid. So 2 pyramids are present, so that it is called trigonal bipyramidal. Here percentage of S character is how much? Sp3d. Sp3d percentage, that means 5 are present. That means 100 by 5. That means how much? 20. So percentage of S character is 20. Similarly, percentage of D is also 20 because both are present 1 1. But percentage of P plus 3. 20 plus 20, how much? 40. 100 minus 40 is 60. That is 60 belongs to P. So this is about percentage of. Next one, bond angle. Here 3 types of bond angles are present. These bonds are called axial bonds. Between axial bonds, bond angle is, because both are present straight line manner, so bond angle is how much? 180 degrees. These bonds are called, these 3 bonds, that means the bonds which are present in plane, these 3 bonds are called equatorial bonds. Between equatorial bonds, bond angle is 120. Between axial and equatorial, bond angle is 90. I repeat it once again, listen carefully. These 2 bonds are called axial bonds. Between axial bonds, bond angle is 180. The bonds which are present in plane is called equatorial bonds. Between equatorial bonds, bond angle is 120. Between axial and equatorial, bond angle is 90. So 3 types of bond angles are present in Sp3 hybridization. This is all about Sp3d. And last one in this case is Sp3D2. That means 1 s orbital, 3 p orbitals and 2 d orbitals. That means intermixing of 1 s orbital, 3 p orbitals and 2 d orbitals to give 6 Sp3D hybrid orbitals. This phenomenon is called Sp3D Sp2 hybridization. Here example is SF6. In SF6 central atom is sulfur. This is the electronic configuration and this is the orbital representation. If you see this orbital representation, only 2 unpaired electrons are present. These 2 unpaired electrons are not sufficient to form SF6. To satisfy that condition, sulfur should undergo excited state. In first excited state, its electronic configuration is what? 3s1 3p4 3d1. 3s1 3p4 3d1. In second excited state, its electronic configuration is what? 3s1 3p3 3d2. Why here we should take second excited state? In case of first excited state, we get only 4 unpaired electrons, 1 2 3 4. These are also not sufficient to form SF6. To satisfy that means to form SF6 again it should undergo second excited state. That means 3s1 3p3 3d2. Now it contains 6 unpaired electrons. One is present in 3s, 3 are present in 3p and 2 are present in 3d. Now these 6 unpaired electrons which are present in orbitals undergo intermixing and form hybrid orbitals. Those are represented by Sp3D2. Now these Sp3D2 hybrid orbitals, that means after forming hybrid orbitals from intermixing atomic orbitals, they arrange octahedrally around central atom like this. Octahedrally, that means these 4 are present in same plane, these 2 are present in, this is present in above the plane, this is present in below the plane. Each hybrid orbital having 1 unpaired electron. This is called octahedral arrangement. Now these orbitals, these hybrid orbitals overlaps with p orbital of fluorine atom. Fluorine also contains 1 unpaired electron. This is the way of overlapping of Sp3D2 hybrid orbitals of sulfur and p orbitals of fluorine. After overlapping, bonds will be formed like this. Then finally this structure will obtain. This structure is called what? Octahedral. ORR. This is square. This is one pyramid, this is one pyramid. Square bipyramidal. This is the shape. Next bond angle. Here 2 types of bond angles will come. This is axial bond angles 180. And between axial and these are equatorial bond angles. I told you these are present in plane. These bonds are called equatorial bonds. Between equatorial bonds, bond angle is always 90 degrees. Next, percentage of S character. In this case percentage, that means 100 by 6. 100 by 6 is how much? 16.66. So percentage of S character is 16.66. Then what about percentage of P? 3 p orbitals are present. That means 3 into 16.66, almost how much? 49.98. Percentage of D, 2 d orbitals are present. 16.66 into 2, how much? 33.32. These are percentages. So this is all about Sp3D2 hybridization. So this is very important topic in competitive level as well as in CBC level. You have to remember all the hybridizations, bond angles, shapes and their percentages. Thank you.